Hello everyone, welcome back to my YouTube channel. Today we are going to see the Maharashtra State Board Class 10 Science 1 Chapter number 8 Metallurgy, and this is the third part of this particular chapter. In the first two videos already we have studied a lot about the metals and the non-metals, their physical and the chemical properties, various reactions and the various steps involved in the concentration of the ores under the basic principles of metallurgy. Now, the secondly, what we have started in the previous video, that is the extraction of a metals. Extraction of a reactive metals already we have studied, we have already begun in that particular section, the previous video. In this particular video, we are going to begin it with the extraction of the aluminium, one of the reactive metals. In that, first of all, the symbol for the aluminium is the Al, atomic number 13, color is a silver white, and the electronic configuration is 283, and the valency is 3. In this particular section, when we are talking about the extraction of the aluminium being a reactive metal, does not occur in the nature in the free state. It's found in the various ores form. And in that, the one which we are going to see over here, or the one of the most important, that is the bauxite. The formula for that is the Al2O3 with the NH2O. The number of water molecules are attached with the aluminium oxide. And the bauxite contains 30 to 70% of the aluminium oxide, that is the Al2O3, and the remaining part is gangue. It is made up of sand, silica, iron oxide, etc. There are two steps in the extraction of the aluminium. In that, the first one, that is the concentration of the bauxite ore, that already we have studied. The first method in the extraction is nothing but the concentration of bauxite ore. So main ore of aluminium, bauxite, from that the silica and the ferric oxide and the titanium oxide are impurities present in the bauxite. Separation of these impurities is done by the leaching process. The first process what we are having is the leaching process, and that leaching process may be performed by the Bayes method or the Hall's method. In both these methods, finally the concentrated alumina is obtained by calcination. So the first they have given over here is the Bayes process, the first ground in the ball mill. Then it is leached by heating with a concentrated solution of a caustic soda, that is NaOH. So you can see that reaction they have given over here. It's forming the sodium aluminate. The sodium hydroxide to form water soluble sodium aluminate. This means that bauxite is leached by sodium hydroxide solution. After that, the sodium aluminate is reacting with the water molecule, the further, it's cooled to the 50 degrees Celsius and is forming the sodium hydroxide and the aluminium hydroxide. In the Hall's process, the ore is powdered and then leached by heating with aqueous sodium carbonate. In the Hall's process, what we have, that is this is leached with the sodium carbonate and is again forming the same, that is the sodium aluminate along with the carbon dioxide gas and the water molecule. And the further, this sodium aluminate is reacting with the water and forming the aluminum hydroxide and the sodium carbonate. The precipitate of aluminum hydroxide obtained in both, that is the Bayes process and the Hall's process, what we have seen just now, is filtered, washed, dried, and then calcinated by heating at 100 degrees Celsius to obtain alumina. So what we are doing, what the precipitate of a sodium aluminate we are getting, or the aluminum hydroxide what we are getting, that is further calcinated or heated up to the 100 degrees Celsius to obtain the alumina. And the second step what we have in this, that is the electrolytic reduction of alumina. Then it goes that alumina what we are having, that we take for the electrolytic reduction. In that, what we are doing, the anode, the made up of a graphite, these are the anode which is made up of the graphite, and the steel tank we are using in this, which is covered or layered from inside. You can see here, if I will enlarge this picture, you can see we have the graphite film attached to this particular tank to make it a conductor. And in this the alumina mixture of the alumina with the cryolite and the fluorspar is poured in this particular container, and the electricity is supplied. Electricity is supplied, then what happens? The electrolytic reduction of the alumina is taking place. So you can see here in this method the electrolysis of a molten mixture of alumina at a 2000 degrees Celsius. It's very high temperature. The tank has a graphite lining inner state, so work as a cathode, and the electrolytes work as anode. And the cryolite, that is the Na3Al F6, and the fluorspar, that is the CaF2, are added in the mixture to lower its melting point up to the 1000 degrees Celsius. Because if we talk about the aluminium itself, it's having a very high melting point. So to reduce that, some impurities like the calcium fluoride, which is also known as the fluorspar, and the cryolite, this is mixed, and the melting point can be brought up to the 1000 degree Celsius, and then the electrolytic reduction is taking place. The anode reaction they have given over here, that is the oxygen forming the oxygen gas, and the cathode reaction, aluminium ion reacting with the electrons and forming the aluminium in the reduction state, and the molten aluminium is comes out of the tank. The next they have given over here is about the extraction of the moderately reactive metals. In that we have the roasting, we have the calcinations. You can see over here the sulfide ores are strongly heated in air to transfer them into oxides. This process is called as roasting. Carbonate ores are strongly heated in the limited supply of air to transfer them into oxides. This process is called as the calcination. So roasting for the zinc, they have given over here zinc sulfide. Roasting means reacting with the oxygen is forming the zinc oxide and the sulfur dioxide, and the calcination, that is the zinc carbonate, is forming the zinc oxide and the carbon dioxide gas. The further they have given over here is about the zinc oxide reacting with the copper and forming the zinc and the carbon monoxide. The next they have given over here is method used for the welding rails. This they have given in the pictures only. They have given about the molten materials are used to welding the rails. The next they have given is about the extraction of the less reactive metals. How to extract the less reactive metals. In this, the metals at the bottom of the reactivity series of the metals are less reactive. That is why they are found in the free state in the nature. For example, the gold, silver, platinum. The reserves of copper in free states are very few. Presently, copper is found mainly in form of copper sulfide. So this copper sulfide is goes under the heating process, that is reaction with the oxygen, is formed the sulfur dioxide and the copper oxide, and this copper oxide is further reacting with the same, that is the copper sulfide forms the copper and the sulfur dioxide gases released. The next is the refining of metals. Refining of metals are very much important process. The metals obtained by various reduction processes described above are not very pure. Means after the extraction, the metals what we are getting, they are not very pure. The refining of that is required to bring the percentage of the metals in the extracted part should go up to the 99.9%. The next what we have to study is the corrosion of metals. Corrosion of metals means whenever one of the metal is reacting with the other elements and forming the some unwanted compounds. In a simple words, that process is called as the corrosion of metals. This corrosion of metals reduces the life of the metal objects. The best example what I can take over here is for the corrosion of a metals is that is nothing but the rusting of the iron. The rusting of the iron, you might have observed, if the iron object we leave it for a few days, then a reddish layer gets formed on the iron material. So that is nothing but what the rusting of iron, and that reduces the life of that particular metal. The further, that is the prevention of corrosion, how we can prevent it. The various methods are there to prevent, because non-corrodable of metals can be used or the non-corrosive layers can be used, or the objects which are very keen to get corroded, that particular metals can be covered with the different non-corrosive materials. In that process, the first what we are having, that is the galvanizing. In this method, the thin layer of a zinc is applied to prevent corrosion of iron or steel. For example, the shining of iron nails, pins, etc. It is in this method the corrosion of a zinc occurs first because zinc is more electropositive than iron. After a few rainy seasons, the zinc layer goes away and the inner iron get exposed. Then iron gets start rusting. So for that, what we have, the first of all, the casting, cleaning, then after that the rinsing, then the picking, rinsing again, then the flux solution, then the drying, then zinc bath, and then the cooling. That is for the final galvanizing process. Next is a tinning. In this method, the molten tin is deposited on the metals. We call this as a kalhe. A greenish layer forms on the surface of a copper or brass vessel. This greenish layer is poisonous. If buttermilk is or curry is placed in such a vessel, it gets spoiled. Tinning is done to prevent all damages. Next is a anodization. In this method, metals like a copper, aluminium are coated with a thin and strong layer of their oxides by means of electrolysis. For this, the copper or aluminium article is used as anode. As this oxide layer is a strong and uniform all over the surface, it is useful for prevention of the corrosion of that particular metal. The next what we are having under this particular section, that is the electroplating. In the electroplating, less reactive or the non-reactive metals can be used. In this method, a less reactive metal is coated on more reactive metal by electrolysis method, like we are having a golden polish on the articles. So what we are doing, the polish of the golden or the gold solution is done on the more reactive, that is the silver metal. Like spoons, gold plated ornaments are the example of the electroplating. And the last method what we have, that is the alloying. Alloying is nothing but what, when two or more than two metals or the metal and a non-metal is mixed in a definite proportion, then that particular product is called as the alloy. So metals are mixed with some other materials to make it as an alloy. An alloy is a non-corrosive material. The majority of the metallic substances used presently are in the form of alloys. The main intention behind this to decrease the intensity of a corrosion of a metal. The homogeneous mixture formed by mixing a metal with other metals or a non-metal in certain proportion is called an alloy. The definition for the alloy. And the examples is a bronze alloy formed from 90% copper and the 10% tin. And then the next they have given is stainless steel, which is alloy made up with a 74% iron, 18% chromium, and the 8% carbon. So these are the methods for preventing the metals from the corrosion. So this is all about the chapter metallurgy. In our upcoming videos, we are going to see some more parts of the science.